For the past 2 years, developers have largely used AI as a targeted autocomplete, typing a line and waiting for a suggestion. Now, a new category of autonomous systems is emerging. These agents can scan entire directories, write code, and execute terminal commands natively, operating with a high degree of independence directly inside the command line. Anthropic's Claude Code set the standard for this workflow. It inspects the codebase, edits files, and runs terminal commands to verify its own work. Teams at companies like Stripe and Ramp have already integrated it into their engineering processes to handle complex, multi-step tasks. This graphic illustrates the resulting shift. The red transition arrow points away from the traditional file-level IDE code editor and toward the agentic terminal. Developers are increasingly moving toward the command line, where the agent has the authority to orchestrate the entire development environment. The preference is shifting away from simple chat boxes. Many developers now want a capable AI operator embedded right where the code is actually compiled and deployed. Proprietary tools like this create a specific friction: vendor lock-in. When you use them, you are tied to a single company's ecosystem and their specific pricing model. If weight limits hit or costs rise, there is typically no way to swap the underlying intelligence. This breakdown highlights who is driving the demand for an alternative. You have the cost and model optimizers, who want to leverage existing subscriptions, and the privacy-conscious teams who require their code to remain on local hardware. OpenClaude emerged to address this gap. It is an open-source command-line interface built to mimic the Claude Code workflow while providing the freedom to switch between different AI providers. The project's public data shows its rapid adoption. This dashboard captures roughly 22,600 GitHub stars and over 7,000 forks, alongside a frequent release schedule. These metrics indicate strong community interest in a modular alternative. The question now is whether the actual mechanics of the tool make it a viable, enterprise-ready replacement for proprietary systems. OpenClaude functions as a universal agent shell. It provides a terminal-first interaction model, allowing users to bring their own intelligence engine to handle reasoning. This architecture diagram shows how the system works. The central interface node connects the terminal workflow to a variety of swappable backends, ranging from OpenAI and Google Gemini to local installations. The loop begins at Step 1, where the developer provides prompts. This flows into Step 2, where the agent orchestrates the task. The process moves to execution in Step 3 with file edits. Finally, Step 4 handles integrations, like the Model Context Protocol. A central feature of this design is settings-based agent routing. As this map shows, a user can assign different tasks to different models, using inexpensive cloud APIs for planning, while routing sensitive code to local engines like Ollama. This setup allows for the orchestration of a specialized fleet of models, each selected for a specific requirement like cost, speed, or data privacy. While the architecture is flexible, a standardized shell does not guarantee the quality of the output. Ultimately, the overall performance of the system still depends entirely on the underlying model's ability to handle complex reasoning. This audit identifies several limitations. The missing evidence block notes a lack of rigorous benchmarks. Operational rough edges mention stability problems with basic tools. Finally, there is the risk of model degradation, where smaller local models struggle to maintain consistency throughout long engineering tasks. Freedom at the interface layer is only one part of the equation. The heavy lifting of software engineering still requires top-tier reasoning capabilities that many local or smaller models cannot yet match. Beyond the technical hurdles, there is a significant hurdle for enterprise adoption: the project's legal status. This graphic details the legal reality stated in the repository's own license file. It contains code derived from Anthropic's proprietary Claude Code CLI. Because that original source is copyrighted, the project's current distribution does not have official authorization. This risk is a clear differentiator in the competitive landscape. While OpenClaude offers high model flexibility, it is categorized as high risk for provenance. Competitors like Aider and OpenCode offer broad model support, but use standard open-source licenses safer for corporate environments. OpenClaude is currently the most functionally versatile option for this specific workflow, but it is also the most legally uncertain. This comparison separates confirmed project milestones from community speculation. The GitHub traction and multi-provider support are verified facts. However, the idea that OpenClaude is a drop-in, enterprise-ready replacement for Claude Code remains speculative. For the project to become a durable standard, it must hit these milestones. Milestone 1 involved resolving its legal provenance and branding, while Milestone 2 requires stabilizing its core reliability and tool integrations. The final verdict appears here at the bottom. OpenClaude is a significant experiment that confirms the high demand for modular agent shells. However, as the warning banner indicates, it has not yet become a de-risked product for production use. Developers can already benefit from testing this workflow locally with engines like Llama. But until the legal and reliability issues are resolved, it should stay out of secure production pipelines.